Welcome back for Chapter 3, Lesson 3, Writing Functions. So our objectives for today are to identify independent and dependent variables. So we're going to learn about what those are. And also to write an equation in function notation and evaluate a function for a given input value. So yes, a ton of vocabulary today. So we're going to go ahead and get started with all of that. All right. So the equation in example 1 describes a function, right? And a function means every domain value has exactly one range value. So if we're looking at the this is the example for example 1. It's a function because every x value, x has one range value, this domain value has one range value, and so on with 20 and 4. Every single one of these domain values has exactly one range value, so we know that it is a function. So the equation in example 1 describes a function because for each x value, right, or input, okay, that means input and x value are the same thing. There is only one y value or output. Okay, so these are some new terminology. So far we have, what do we have? We have x value. We have input, which means the same thing as x value. We have domain. So those are 3 different ways to write and express just x. Okay, and then what do we have for y? Well, we can state that we have the y value, right? Or the output, or the range, and that's the y. So there's 3 different ways to express all of the same thing. This is all just talking about y. This is all just talking about x. So terminology. It's so important to know that all of these words mean the same thing, because if you know that the input is the same thing as x is, then really everything you know about x applies to input, okay? And the same thing is true for the output. Everything you know about y applies to the output because the output is y. So just understanding terminology, it just really helps, because then you don't see all these as separate things. You start to see similarities within this group and this group. Okay, so this says the input of a function. So the input, what is that? That is the x value, right? So the x value of a function, or the input, is the independent variable. Oh my goodness, we have another one. There's another name for the x value. It's called the independent variable. So independent variable, did I pen dent? Why am I having a hard time spelling today? Okay, independent variable. We got the independent variable, the x value, input, domain. All of those things mean the same thing. Let's go down here. The output, the output, what is that? Oh yeah, that's y. The output of a function is the dependent variable. Are you serious? We have another name for y too, the dependent variable. Okay, so the value of the dependent variable depends or is a function of the value of the independent variable. So the dependent variable depends on the function of the value of the independent variable. All right, perfect. Okay, let's start and look at this particular example. So what we know is that x is the independent And y is the dependent variable. So y depends on what happens to x. So x starts off as it is, and something happens to x, and whatever you get for y depends on what happens to x. All right? So what we're going to do with this table is determine a relationship between the x and the y values and then write an equation. So the first thing you want to do is list the possible relationships between the first x and the first y. So what is happening? We start with this, and then what happens to it to get 1? Well, it gets smaller. And what you have to know is that when numbers get smaller, they can either get smaller by what operations? Well, subtraction, right? A number can get smaller by subtraction or division, or really maybe just a combination of subtraction and division, right? That's how numbers get smaller. So there's a couple different options. How does 5 become 1? Well, the first option would just be subtraction, right? 5 minus 1, and 5 minus 1 equals 4. Okay. Perfect. So that's one option is subtraction. What would be a second option for it getting smaller? Well, I think that would just be 5. If we divided it by 5, then we would end up with 1, right? Okay, so those are two ways. Oh, wait. This first option is supposed to be 5, take away 4. And then you get, where's my correction tape? Okay, I might have just totally confused you. Okay, so the first option was subtraction. So if we go 5 and we take away 4, then we get 1. I totally wrote that wrong. So 5 take away 4, and then we get 1, which is that y value, right? So we have basically, what do we have here? We have our x value, and then we subtract 4, and then we end up with our y value. And then what do we have here? 5 is our x value, divided by 5, and then we end up with our y value, 1, okay? So that's kind of what we're doing with both of these options. So we have figured out what the relationship is between 5 and 1. 5 gets smaller, and it can either get smaller through subtraction or through division. But now what we want to go to is step 2. We want to see if one of these relationships, either the first one or the second one, works for the remaining x and y values. So then what we're going to do is we're going to go here. We're going to take this first option, except now we're going to use this x value of 10. And what we want to do is we want to see if this same taking away 4, right, if that works here. So if we take 10 and we do the same thing, we take away 4, do we end up with 2? No, 10 take away 4 is 6. So that means this first way does not work. Does not work. Okay? Oh, look at the little, it's like a little sad face. It doesn't work. So how about we go to the second option? Okay, so this means we take that x value 10, and then we divide it by 5, and do we get 2? 10 divided by 2 is 5. Yes, we do. We got it. It's a happy face. Okay, that one works. Okay, well, we have to try these other numbers. Well, what about if we take 15, and what are we doing here? What are we doing to this number? We're dividing by 5, and then we divided by 5 again, right? So let's see, when we take 15, and then we do that same thing, we divide by 5, do we get 3? And 15 divided by 5 is 3, so that works. So that's a happy face. And what about this last x value of 20? If we take 20 and do the same thing, our same process, what is our process? It's dividing by 5. Do we get 4? 20 divided by 5 is 4. So yes, we got it. So this same process of dividing by 5 works every single time. So now we just need to write an equation. So what do we notice about all these values on top? 10, 15, 20, those are all the x values. So the x value was on top, and then we divided it by 5. That's what we did every single time. And that equals, what are all these values? 2, 3, 4, 2, 3, 4. Those were the y values. And there's our equation right there. All right, let's go ahead and look at a different example. Oh, wait, that was all kind of messed up. All right, there we have it. There's our equation, y equals x divided by 5.